How simple is simple interest? Spoiler alert, it's really simple. But what makes it so straightforward? Let's dive into some math and find out. Let's start with a quick example. Imagine you borrow $1,000 from a friend for 1 year at an interest rate of 5%. Let's break this down and see what we've got. We've got the amount, a time period, and the rate. We've lined up these details and we multiply them. Don't worry, we'll get into why we need to multiply these to find the interest. These values stand for simple interest, principal, rate, and time. With these, we get this formula, which shows how to calculate simple interest. To solve this, we can either convert the rate to a decimal by dividing by 100 or divide PRT by 100. Both ways work. Now, let's calculate the interest. Interest equals 1,000 times 5 over 100 times 1, which equals 50. The dollar sign is re-added to indicate the amount in dollars, but this is just the interest. To find the total amount to return to our friend, we add the principal amount. So, the total amount to return equals principal plus interest, which gives us $1,050. Now let's dive deeper into this example and see what's really happening here. Let's plot a graph to visualize how interest grows year by year over different time periods. On the x-axis, we have time in years, and on the y-axis, we have the interest in dollars. The graph shows our initial interest value growing steadily over time. Let's start plotting the data points. As we plot data points for interest over time, notice the pattern emerging. You can see two distinct patterns here. Each dot represents a $50 increment in interest for every year. Connecting these dots with a line illustrates the linear growth of simple interest. This is a linear plot, unlike the exponential curve we see with compound interest. In simple interest, we'll always get linear growth. Let's highlight specific points like 6 years and 12 years and their corresponding interest values. By creating a right-angled triangle, we can better understand the relationship between time and interest. The angle theta, formed by this line with the x-axis, is the same as the angle inside the triangle. Now let's determine the slope of this line using this right-angled triangle. The slope is the rise over the run. The base represents the run, and the height represents the rise, showing changes in time and interest. Rise over run can also be expressed as the change in y over the change in x. We also know that the slope is the tangent of the angle theta. Let's calculate the slope by finding the change in y and the change in x. Substituting these values in the formula gets us 50, which is also our unit change per year. The slope representing the constant rate at which simple interest accrues over time. It is also the tangent of the angle theta, meaning that variations in theta will change the slope. As theta increases, the values for tan theta become larger, and as theta decreases, the values become smaller. Now, let's introduce the line equation of this line. Y equals mx plus c. The y-intercept c, in this case, is 0, since our line passes through the origin. So we get y equals mx. But what do y and x represent in our graph? We can substitute them in the line equation. Now, for these two equations, let's keep the left-hand side the same as SI over t. Combining these two gives us m equals PR. This equation shows that the slope is directly proportional to P and R. This means that interest over one interval of time is determined by the slope. PR just gives us that directly. And multiplying this with the number of intervals, we get the total interest. In simpler terms, PR gives us the interest for 1 unit of time, and we multiply it by T to find the total interest for the desired number of time intervals. This is why we multiply these values together. All of this leads us to the simple and elegant formula SI equals PRT. Simple enough, right?